Hello everyone, in one of our previous videos you got acquainted with functions written in ST. If you happen to miss it, no worries, the link is in the description below. Today, we'll take a look at how ST function blocks work. Unlike functions, a function block can have multiple outputs and can retain the state of its internal variables from cycle to cycle. This makes it perfect for implementing things like a pulse counter. Let's jump into ALP and take a closer look. As you can see, next to the button for creating an ST function, there's a button for creating a function block. When you click it, an ST editor window opens with a block template. Let's use a pulse counter as our example. First, we declare the name of the function block. Then we define the input and output variables and their types. For the inputs, we have UN variable of type bool. The output increases on the rising edge of the pulse at this input. DIN variable of type bool, which causes the output to decrease on a rising edge. RIN variable of type bool, which resets the counter to the value of another input variable called NIN of type UD integer. We'll also add one output variable QOUT of type UD integer. After declaring all the variables, we move into the body of the block, where the algorithm is implemented. In this example, it's fairly simple. At the end, we assign the final values to the output variables. Once the block is created, it's automatically added to the local library and will be loaded onto the device with the program. Keep in mind that function blocks consume memory, even if they're not used on the canvas. Simply having them in the library will take up space. So, it's a good idea to remove any unused blocks from the library. Let's drag our block onto the canvas and simulate how it works. As you'll see, pulses at the input are counted correctly, and the value can be reset using a dedicated command. Just like functions can call other functions, function blocks can call other function blocks. To do this, declare an instance of the block as a local variable and call it appropriately in your code. For example, here we call a standard counter block. Up to 8 levels of nesting are supported. You can access the inputs and outputs both inside the block and from anywhere in the program by referencing the block's name, followed by a dot and the variable name. This behavior is very similar to what you'd expect in CodeSys, with a few light limitations, all described in the ALP documentation. Now, here are a couple of useful features we've already implemented. We've added the ability to export functions and function blocks written in ST as files, just like macros. This makes it easier to transfer your custom code between projects. We also added the option to import those blocks into the component manager, so your best work is always within reach. Just open the component manager, go to the local library, and import your file. Simple and efficient. And here's one final tip. If you're just starting out or want to build a small project for yourself, ST can be your best friend. Modern AI chatbots understand ST very well. You can literally ask them to generate specific blocks for you. In fact, our own akYtec AI knows ST, and it's also aware of ALP's specific limitations. That means it can help generate code more accurately than a general assistant. In future videos, we'll start diving into practical examples of how to implement common tasks using functions and function blocks in ST. Let us know in the comments what kinds of algorithms you'd like to see. And if you have suggestions for how to improve ST or ALP, feel free to email our technical support team. We'd love to hear from you. Thank you for your attention. See you next time.